This video is going to walk through some of the examples for section I on complex numbers in iXL. So I'm just going to go through some of the basics with this. Some of the sections I want to spend a little bit more time on than others, especially this powers of I one down here at the bottom. So first we have introduction to complex numbers. This is mainly going to be simplifying square roots with i's in your answer. So remember, anytime we're taking the square root of a negative, that is going to give us an I. So I'd take the square root of the 16, which is 4, and then I put the I in there, and that's all they're looking for this one. Notice this one, the negative is outside, so you would have a negative in your answer, and then the square root of -4 is going to be 2i. And you can see there, if we submit that, that's going to give us the correct answer. Now I am going to jump a level here so you can see like a question like this where you need to simplify. So we have the negative square root of -2. So my answer is going to be a negative. Because of the negative inside the square root, I am going to have to pull out the I. However, 2 only has perfect square factor of 1. So that 2 is actually going to stay in. So this is going to be 2i square root of 2 is how you would write that answer. And they're going to continue through that. You may have to break some down. Like, for example, this one, the 11 out in front, you would only combine that if your radical ended up being a real number, which in this case it's not. So we are going to have 11 minus. You would pull out the I from the negative in the square root, and then the 6 would have to stay in as a positive. So that's the basic idea behind I.1. I2, that's another one that's pretty easy. All you're going to be doing here is combining like terms. So like, for example, this one, both my terms have i's in them. So I combine the coefficients in front, which is going to give me a 14i. Notice it is not squared because when you're adding i's, you are not changing any exponents. The changing of exponents only happens whenever you multiply. Now let's skip here and see if we can find one a little more difficult. Again, that one you're just combining all three of those together. Those are still all i's. Let's try something else. Okay, here we go. So this one, you actually have two complex numbers. Notice it says your answer has to be in the form a plus bi. I am adding, so I'm going to combine my real terms. The -10 and the -4 is going to make a -14. The 8i and the 3i is going to be plus 11i. Okay, so just be careful if you get a subtraction. Remember, you do have to distribute the subtraction to both terms. And I'm trying to see if they can give us one like that. And again, they do get a little more complicated just because they keep adding terms, and then you get some decimals in there. So that is I2. And then we have I4. I4 is multiplication. It starts out simple. Like, for example, this one, 4 times 4i is going to be 16i. This one, again, is very similar. Then eventually it's going to move you into distributing. So, for example, this one would be -12 minus 16i. This one is also distributing. This one, you would have to use the fact that I squared is equal to -1. So your -5i times your -4i is going to be a positive 20i squared. But remember, I squared is -1, so this answer is actually going to be -20. Okay, let's see if we can get a FOIL question. It's getting closer. So I guess these, it's going to be a while before you get to the multiplication like that. Here we go. Okay, so for this one, you would have to go through, and I'm going to type this on the screen because it's a little neater than me trying to write with the mouse. You would multiply the -2 times the +2, which would give us a -4. The -2 times the -3i, which is going to be a +6i. The 4i times the 2 is +8i. And the 4i times the -3i squared is -12i. And that would be squared. So I'm just going to put that 2 after that to remember that that's squared. So the I squared is equal to -1. which means this negative 12i squared is actually going to become a positive 12. My 6i and 8i are going to combine together to become 14i, and then the 12 and the negative 4, I would add that together to become a positive 8. So your final answer is going to be 8 plus 14i. Okay, and again, this is another FOIL problem like that. Okay, now we get into some of the ones, well, this one is probably going to take the most amount of time. This is dividing complex numbers. So first of all, if you have one term in the top and one term in the bottom, you are able to cross i's out like you would if they were x's or any other factors. So these i's would divide out, the minuses would divide out, and you're actually just going to be left with the fraction 5 over 2 in this case. This one is another one that's similar to that. Okay, and so now you have one like this. So we have 1 divided by negative 4i. This one you are going to have to use your, you are going to have to multiply, but instead of multiplying by the complex conjugate at the bottom, anytime you have a single term in the denominator, you are allowed to multiply by just I over I. So this would be 1 over negative 4i times I over I. And the reason for that is anytime you multiply two i's together, you're going to end up with I squared. So whenever you multiply by I over I, you end up with, and I'm going to type this in the box so you can see what it looks like, you end up with I over negative 4i, and then I'm going to put the 2 there to indicate that it is squared. Now, if you recall, again, I squared is equal to negative 1, so that negative 4 in the bottom is actually going to change to a positive 4. So your answer for this one is actually going to be I over 4. This one is actually the exact same question. So again, if you have just a single I term in the bottom, you're going to be multiplying by I over I. You could multiply by positive 4i over positive 4i. You just have to make sure you reduce your fraction at the end. This is another one where you would multiply by I over I. You end up with, I'll show you. When you multiply by I over I, you end up with 3i over I squared. And again, I squared is equal to negative 1. 3i divided by negative 1 is actually going to eliminate your fraction and give you a negative 3i. So when you have a single term in the denominator, if it's an I, you can work on it like that. This would also be the same way. When you get into the more complicated ones like this is where you need to multiply by the complex conjugate of the bottom. So we have 1 over 2 minus 3i. I'm going to multiply top and bottom by 2 plus 3i. So 2 plus 3i over 2 plus 3i. So your top is going to become a 2 plus 3i. And again, I'm going to type this in the fraction. So 2 plus 3i. The bottom, 2 minus 3i times 2 plus 3i. I'm going to type out what you get before you simplify. So you're going to get 4 plus 6i minus 6i minus 9i squared. Now again, the plus 6i and the minus 6i, those are going to add out to 0. Minus 9i squared is going to become a plus 9. And then 4 plus 9 is 13. Now, notice it says that it wants the answer in A plus BI. So you can't actually leave your answer like this. You would need to rewrite this as two fractions, as 2 over 13 plus 3 over 13i. I'm going to come back here and get rid of this. So I need a fraction 2 over 13 plus, I need another fraction 3 over 13, and then I would put the I right next to it. For this I term, you can put the I in the top, or you can put it off to the side, but it cannot go in the bottom. And so that's how you would do the division questions. The last section is very interesting. with the powers of I, because of the way that I actually coordinates with each other, I cycles through 4 different options. It's never going to be something different than one of those 4 options whenever you have I to a power. So when you're doing this type of question, you want to think about, how can I rewrite this power as something that I know? For example, I to the 4th is I squared times I squared. And I squared is -1, so -1 times -1 is going to end up being +1, which would be my answer for this question. Note these answers here. These are the only 4 answers that a power of I can equal. And it all depends on how many times 4 divides into the exponent. So if you have some exponent of I, and when you divide 4 into it, you get a remainder of 1. For example, I to the 5th. 4 goes into 5 one time, but the remainder is 1. Anytime you have something that has a remainder of 1, that is going to be the same as I to the 1st power, which is just I. Anytime you divide 4 into the exponent and you get a remainder of 2, that is going to be like an I squared. So that is going to give you a -1, which is down here. Anytime you divide 4 into an exponent and you get a remainder of 3, that is going to be the same as I to the 3rd, which is a -I, because I to the 3rd is I squared times I. And then lastly, if you divide 4 into the exponent and there is no remainder because it divides completely, it's going to be the same as I to the 4th, which is 1. And it's always going to cycle through those options. It's going to be I, and then -1, and then -I, and then +1. Even exponents are going to give you 1 or -1, depending on if it's divisible by 4. Odd exponents are going to give you I or -I, depending on whether you have a remainder of 1 or a remainder of 3. And that's the basic idea behind these. I'm going to jump a little bit so we can see some of the later ones. I can talk you through those. Okay, for example, I to the 14th. So I would take 4 and divide it into 14. Well, 4 goes into 14 3 times, which gives me 12. 14 minus 12 is 2, so 2 is my remainder. So 2, that's the same as I squared, which means this is going to equal -1. Notice it was an even exponent. Even exponents are always going to be 1 or -1. So I to the 73rd power, this is an odd exponent, so I want to see how many times 4 divides into 73. So if I divide that, 4 goes into 73 18 times, and you have a remainder of 1. So since there's a remainder of 1, that's going to be the same as I to the 1st power, which is just I. So even positive exponents are going to follow that pattern. It is going to be a little bit different for negative exponents. And if you write out the pattern and you think about what it is backwards, you'll be able to figure that out of how it actually changes. Because, for example, if you have I to the 1st power, which is I to the 2nd power is -1, but if and I to the 3rd power is -I, and then I to the 4th power is +1. If we go backwards, we have I to the 1st is I to the 0 is 1. Anything to the 1st power is, or to the 0 power is 1, and that also fits our pattern. That means I to the -1 power is actually -I to the -2 power is -1. So it actually works out that for the negative even exponents, they are going to be the same as what the positive even exponents are, but the odd ones are actually going to be opposite. So I's to negative odd powers are going to be opposite what they would be if those powers are positive. Let's see if we have one up here. For example, this is what I just said, I to the -1. So if we count backwards, I to the 1st is just I to the 0 is -1, I to the -1st power, if I go back through my cycle, right before +1, I get a -I. So this is actually the same thing as -I. If it was a positive 1, it'd be positive I, but since it's a negative 1, it's negative I because it's opposite. And again, I to the negative 2, the odd or the negative even exponents are going to be the same as the positive even exponents. So this is still going to be a negative 1. Just something to keep in mind as you work through this. So I hope this was useful for completing your iXLs on some different things with complex numbers. Go back through and watch anything that doesn't quite make sense and contact me if you have any questions at all.